Hello everyone and welcome to video 5H. This is trigonometry applications for non-right triangles, and that of course means when it's a non-right triangle that we will be using the laws of sines and cosines in order to solve these problems. So the word problem that you have at the top of your page is a surveyor is able to determine that the angle between the lines of sight to two trees in the distance is 32 degrees. His equipment tells him that the distance to tree A is 100 meters, and the distance to tree B is 75 meters. The question that we're asked to solve is how far apart are the trees? So now, just like in the last video, when we have an application word problem that involves trigonometry, it's always really helpful and almost essential for us to draw a diagram that represents the information. So I have a picture here for you guys, and hopefully you can see the surveyor in this work here. And the surveyor's equipment has a 32-degree angle between the two lines of sight from tree A to tree B. Remember, the distance to tree A is 100 meters, so this is A here. And tree B over here is the distance of 75 meters. Our question is, how far apart are the trees? So that's this distance right here. And as you can see, we do not have a right angle anywhere in this picture. So we're definitely going to be using one of our laws of sines or cosines in order to do this problem. And as you can see, this is an example of side angle side, meaning that we have the angle between two given sides that we know to begin with in the problem. And so I hope you remember from our laws of sines and cosines videos that a side angle side combination is going to be our law of cosines that we're going to be using to solve this problem. So if we call this x right here, then we would say that x squared would equal 75 squared as one of the sides, plus 100 squared as the other side, and then minus 2 times 75 times 100, and then times the cosine of the angle that is opposite that unknown side. So that's going to be my 32-degree angle. And so that's the cosine of 32 at the end of that line there. As we simplify, in our next step, we're going to have x squared equals the square of 75 is 5,625. The square of 100 is 10,000. And the coefficient that 2 times 75 times 100 in front of that cosine of 32 becomes is 15,000. Simplifying a little bit more, in the next step, remember, we can only combine these two constants. We cannot combine it with this third number over here because that's glued with multiplication right to the cosine of 32. And so we'll have 15,625 when we add those together, minus 15,000 times the cosine of 32 degrees. And of course, using my calculator, and we have two steps, we're going to find the value of all of this in one step on our calculator. And then to go from x squared to x, we're going to take the square root. So that's the two-step process that was shown to you in the screenshot video. And my approximation for x here is 53.9. And of course, since it's an application problem, we want to make sure that we attach the units from the problem to the answer. And so my final answer here is 53.9 meters. So that's the first example of using the law of cosines to solve a trigonometry application problem. As we move on down the line here to our next example, we have the distance from a water tower to a forest fire is 1.5 miles. From the tower of a forest ranger's station, A ranger sights the angle between his lines of sight to the water tower and to the forest fire as 34 degrees. A fireman has reached the water tower ahead of the ranger and radios to the ranger that there is a 97-degree angle between his lines of sight to the ranger's station and the forest fire. And the question that we must solve is, how far must the ranger travel to reach the scene of the forest fire? So again, I have a picture for you guys here. And this is what we're looking at. I know that it may be a little hard to come up with a picture on your own, so I wanted to provide one for you so that you can start to think through how to sketch it. So again, let's look back at the reading of this problem. It says the distance from a water tower to the forest fire is 1.5 miles. Now, of course, we can always start by sketching a triangle. You can ignore the 150 feet. This is 1.5 miles here, okay? From the tower of a forest ranger station, a ranger sights the angle. So here's the ranger tower right here. And the ranger is sighting the angle between the two lines of sight, one line of sight to go to the water tower, one line of sight to go to the fire, is going to be 34 degrees. So that's the angle that you see. Then we have a second person who's reached the water tower here ahead of the ranger and tells them that the difference, the angle between their two lines of sight to the other two corners of that triangle is 97 degrees. And so the question is, how far must the ranger travel to reach the scene of the forest fire? So this is my unknown, which is x. And remember, we're going to keep this as our 1.5 miles. So as we look at this picture, we can see that this is an example of angle, angle, side, two angles and a non-included side, in other words, and we're being asked to find a side. And hopefully you can remember that this is going to give us our law of sines in order to solve this problem. The law of sines tells us that the sine of 97 degrees first over the side that is opposite the 97 degrees, which is our x, is going to be equal to the sine of the other angle in the triangle, which is 34 degrees, that angle at the ranger's tower, divided by, again, the side that is opposite that 34 degrees, which is going to be 1.5. As we cross multiply, we get 1.5 times the sine of 97 equals x times the sine of 34. Now we need to solve for x, so we want to divide by the quantity sine of 34 on both sides. And when we get x alone, it's going to be equal to 1.5 times the sine of 97 degrees all over the sine of 34 degrees. And using my calculator to find an approximation in that final step, we get 2.7. And of course, because it is an application problem, we need to put this back into the units that are given in the problem, which are miles, remember? So we'll say 2.7 miles. And that is the end of video 5H. There is an example on the back for you guys to attempt to use the law of sines and cosines. We do not show you the solution in this video, but hopefully you've had enough instruction on this type of problem, both in the regular videos of 5E1 and 5E2 and 5F1 and 5F2. If you need to go back and re-watch those, I would recommend that you do that to just practice with the laws of sines and cosines. And that's the end of our time together. So hopefully you've enjoyed this flipped classroom change, and we'll see you guys tomorrow.